Hello everyone, my name is Franco Pucci. I'm the technical consultant for the STS Association. Welcome to Training Video Series 2, where we will explore the companion specifications. I hope you find these videos helpful. In this video, we will look at an action request, an action response, a GET request, a GET response, message definition in ASN.1 format, a response message, and a worked example. Now, if you remember from the previous video, we said we were dealing with the STS COS token carrier type defined in STS101-2, or also known as the STS token gateway. And we also looked at the message interchange, the enter method, where the token went from the head-end system through to the token carrier. An action request was generated. The STS gateway then generated or used an enter method to get its data, send it through to the meter application layer. The meter application layer would verify the token, send it through to the meter. The meter would generate a token result, and that token result would then be sent through to an action result, an action response, and finally a token status back to the head-end system. The action request has the following fields. It's got a token data type, which is a required field, an ID record, which is an optional field, a print record, which is an optional field, and of course the token, which is a required field. So let's have a look at each of these in turn. The token data type indicates the data format of the transmitted token. This could be, for example, a 66-bit token or a bulk token. The token data type format, the element is a token data type, the format is an integer, the range is 0 to 99, and the carrier would be a request message. The following token data types are defined in STS101-2. 66-bit token data, the token length is 66 bits, and the token data type value is a 0. All of the rest, 1 to 99, are in fact reserved for future use and are unspecified. The ID record in the token carrier data unit, and for this you can see video 29 in series 1 on the IEC 62055-51 if you want any explanations of TCDU. But the meter pan is 18 digits, the date of expiry is 4 digits, the token carrier type is 2 digits, the encryption algorithm is 2 digits, the supply group code is 6 digits, the tariff index is 2 digits, and the key revision number is 1 digit. The ID record, IEC 62055-41 defines the ID record as 35 digits. Transmission of the ID record is optional. The POS should include the ID record unless it has access to meter configuration data that selects to exclude the ID record. The PRN record is a free-form field that allows you to transport data to be printed onto the token carrier if so desired. And typically this may have been, for example, in a magnetic card where you could print information on the card, or even if you print a token and your token carrier is a piece of paper, you could do so. It is an optional field and is unspecified. Typically, this would be some text that is printed onto the token carrier. Then the token itself, this is a 66-bit token value that is sent as the token. And if you look at it, there's an example. For example, there's a long strings of ones and zeros, that's the binary number. The hexadecimal value, which is actually what is sent along this channel. And then the representative decimal value. As we all know, that's the 20 digits split into 5 sets of 4 digits. This is typically what is printed on a piece of paper as the token, but the hexadecimal value, the one above it, is what is actually sent. Now let's see what comes back when processing a request. The action response, the meter back to the point of sale, it has the action response has the following fields: an authentication result, which is a bit string of variable length, a validation result, which is a bit string of variable length. The authentication result tells us whether the token itself was authentic, and the validation result tells us whether it was a valid token. Then you have a token result itself, which gives you the final answer, I reckon. And then the ID record result, which is also a bit string of variable length. Let's look at these in turn. The authentication result is a bit string, which contains result values from initial authentication checks of the token that it's just received. So typically, if the token is authentic, the hex value would be 1, or the bit string would be 80 hex. Now, please remember that the bit string is actually reversed, so the least significant bit is on the left. CRC error is 02. Manufacturer code error is 04. And the rest are reserved. Okay, as I mentioned before, the bit string values are read left to right. Validation result. Here we have the following possible values. Valid, 01, an old error if you inserted a token that was older than the oldest token in the TID stack. Used error if the token that you played to the meter had already been used before. Key expired, key expired error if the meter key has expired, or if you're trying to send a credit token to a meter that's coded with a default key, which is not allowed, and all the rest are reserved. The token result is the 66-bit token value that is sent as the token. This is a status indicator from the meter application process to convey the result after processing the token. Here, there's quite a few more. 01 means the token was accepted. Then you've got first key change token, second, third, or fourth key change token. EA 11 meters have 4 key change tokens. EA 07 meters have either 2 or 3. So you need to state which token was sent and accepted. So it'll be first, second, third, or fourth. You could have an overflow error if you put in too much credit and the meter credit is already full. Or the amount that you've sent in the latest token would result in the meter overfilling its credit register. It would then send you back an overflow error. Key type error, if the meter is in the incorrect key to receive the token you've just sent it. A format error if the command has been formatted incorrectly, or a range error. For example, you try to send it a tariff index of 100 when the tariff index range is 0 to 99. A function error, for example, you may try to send a water meter token to an electricity meter. This would result in a function error. Invalid token data type, or the rest are reserved for future use. The ID record result itself will then come back as meter configuration OK, meter pan mismatch if you've sent it an incorrect meter pan. The next two are not used. Then you could have an EA mismatch. In other words, you're trying to send an EA07 token to an EA11 meter, or vice versa. SGC mismatch, tariff index mismatch, or key revision number mismatch. And those essentially are the ID record results that can come back after ID record processing by the meter. And we're going to be continuing with STS101-2 specification in the next video. Then there's a GET request point of sale to meter, where you have the STS token carrier, the DLMS server, and the STS token gateway. Once again, you get information from the most recently processed token. The GET request, along with any attributes, go through to the server, through to the token gateway, and then an action result is generated, and it comes back through the token carrier to the head-end system, or the point of sale in this case, as a token description. And for this you need to see IEC 62056-6-2 for the GET request format. The token description contains the token class, the token subclass, the token ID, the token amount, and all of them are in octet strings. We did cover this briefly in the previous video. The GET response format, if you have a look at it, you've got, for example, class and subclass, class 0 being credit, subclass 0 being electricity. The ASCII representation could be credit transfer for that token, and it could be electricity for the subclass. So, example 1, we have a class 0 token. The amount is 10 kilowatt. The TID value is 123.55 minutes. The token description then looks at the token itself, which is the top one, 4352, etc., etc. The subclasses 454C, etc., which in fact is electricity spelled out in ASCII format. And then you have the, following that, you have the TID value, 123.55, and hex is 01D623. And then you have the amount, which is 3130-2E3030, which is 10 kilowatt hours. Any field that is not applicable shall be represented by a null data value. This brings us to the end of this part of the video series. I hope you found this video helpful, and I hope to see you for the rest of the video series. Goodbye, and see you again soon.